Good. So, uh, so let me start with introducing the course and the content that we expect to learn, right? So this is as you may have studied the uh, program module handbook. This is an introductory course into a programming language that would be useful for economics. So in that way, economics, not only econometrics, so we discussed internally which one would be the best to equip you guys. And in the end, we were wondering between MATLAB and Python. And then we decided to choose Python because Python is an increasingly popular multi-purpose programming language, and it is free. So for the MATLAB, sometimes comes to the problem of having the access to the license that could hinder your application in the future. So we have made this choice, right? So this is an introductory course. So basically the outcomes when you have finished taking the course, one is that you will be able to clean to summarize the structured data. So up until now, you have been mostly exposed to already created complete data set for researchers, right? So let's say if life seemed to be very easy for you guys, right? So you just load the data in, run the commands. Either you have a graph, a table, or a table, and that you would start interpreting. But life is not like that. Actually, I can tell you for a researcher's life, 80% of your time is about creating data, cleaning data, because data is king. If you have the data, you will be able to produce the research. So the data is scattered all over the places. And it is the training in math, in finance and economics that would give you the idea what you want to do and which data you want to select and collect. Okay, so in this context, we would need to develop skills that would allow you to independently develop a research question, identify the data sources, assemble them into a clean data set before you can start analyzing, right? So in this way, the first step in order to get that is to make sure that all of us are familiar with Python. So I know that the background here varies a lot. Some of you have even written the thesis with me. Uh, some of you are trained in computer science. I would have specific expectations for you. And for some of you who have a more social background, don't worry. We start from the beginning today, right? So in order to do that, I have studied the materials and I decided to focus on firstly on something that you know very well, something that is simple. We get used to the language, right? So Python in the end is like a calculator, and it can calculate very complex data set that a simple calculator would not be able to do, right? So let's say the first thing we want to do is to get used to Python. Python is not easy to get used to because it is a versatile programming language. Everyone uses it. So in order to get used to it, you must know what you want. For example, if you want to take a simple sum of 1 plus 1, then you would immediately ask Python to do that for you. If you want to compute an inverse of a matrix, you should know how to ask Python do that for you, right? So some of you would say no, but I know all of that via ChatGPT. That's the problem. Because everything ChatGPT can provide, that means that you know nothing. Every time you need something, you would go to ChatGPT. So what is there in your head? You need to develop a systematic framework where you accumulate the knowledge, what and when and how to use Python. From that starting point, when we get stuck somewhere, we would ask the ChatGPT or Google Gemini to assist in producing that snippet of, of code that you want to create, right? So in this case, what the course guide you through, one way is to ask you to code on the paper. I would not do that because what for, right? What for? It only works for the computer science guys who really want to grow a deep understanding of the semantics of the programs and maybe to develop the programs later, other languages later. But for us, I think it's better to say we develop a skills. Firstly, we identify what we want to compute. Secondly, we develop the skills how to ask Python to compute what we want for us. That's it, right? So the course will be very much focused on the linear models. We start with the OLS. We manually compute all statistics that up until now have been computed by the written routine that you just, you put in the independent variable, the dependent variable, you get the statistics and you start interpreting. That is no longer the case. Now, firstly, we will learn to do descriptive statistics, and you will see that in Python, if you don't use a certain written library, it will be very awkward. And how to bring all of the necessary information into one table. That is the first step. And then how to produce. So you see that whenever you run a regression command, you have a beautiful table. But now it's not your job anymore. You can do that, but you have to program yourself. So after the second day or the third day, you would have a program like Dan Thư or Khánh Linh. But then in brackets, you put in the variables and it will produce the results, right? So you don't have to use OLS anymore. So you have to be able to write the function yourself, right? So in order to do that, ChatGPT won't help. But if we just rely, again, what I'm saying is, if we do not really understand the language, ChatGPT would make us an uninformed user. So we develop the skills that without ChatGPT, we have to be able to code ourselves. But with ChatGPT, we will do it faster. That's the idea, right? And in this world, we need to really rely on the AI. It will be completely a disaster if I say, no, we don't rely on the AI. Right? Because I am not as good as ChatGPT for sure in terms of coding. I mean, my code could be less efficient, more messy and everything, right? So why don't we learn from both, right? Okay, and in the end, the course will reach a second level when you are given a database. And the database is produced by certain statistical agency like the General Statistics Office of Vietnam. The database are collected from the survey, for example, and given to you without any prior set purposes. So regardless of who the researchers are, they would use the necessary methods to calculate the data that they need. And in order to do that, we will go from the raw data into produce replicating a paper. That took me about 2 years to finish. Of course, that's an exaggeration in the sense it would take me about 2 weeks to finish the calculation, and then refining, and then we submit it to a journal. We get rejected, and then or we get reviewed. We have to revise. So let's say I would guide you through, and my goal, the ultimate goal after this course is from now on, if you identify a research question, you would be able to identify the formulate. You would be able to formulate a solution. Based on that solution, the crucial part is to identify the data sources, get the data, and assemble them into a data set that is ready for analysis, right? Analysis. So this is something that I was not taught when I was back then as a master's student. Everything we did was in a complete data already, and we would not understand how we would proceed. And when I started my PhD education, they gave me a year just to focus on learning myself how to do that. So there is a pro and cons here. Sometimes you ask a professor from the Western university, how can I do this? How can I do that? They would say they don't know. And they appear to be quite stupid. But no, that's their style. They would not teach you the specifics. You have to figure out yourself. And sometimes it could take people several years to get to that. But let's say my take is we not only we are not only people who will do a PhD. We are also people who will start working after this. It's not necessary to do a PhD to be successful. It's just the career path, right? So let's say we should learn at this moment on how to start the research from scratch till the end. And that would help you a lot with your master thesis, with your thesis seminar, and I think other courses will again focus on the completed data already. So, and then the second purpose of this course is after this, you will do another course with Professor Mehdi Hossein Kochak. So Hossein Kochak is a very versatile researcher. He prefers Python in his course. And I have heard from several, all of the students, he is one of the best lecturers, very enjoyable lectures from him, right? So in that case, he needs Python as the input. So this course, so if you do this one well on the foundation that we have laid, then you can go on with his course in a more prepared way. Right? That's what I have. So let's say this is what we are going to do, right? So first one, I will run you through introduction to Python. And then we would have some analysis using the descriptive statistics, right? And then I will go to the OLS model. So with the OLS, we will program the OLS ourselves. We will program the tests that we have used like a routine so far, right? So in the pre-master course, I did show you I derived the results for you. And if we wanted to do some tests, we put in the written command. Now we have to write that ourselves. We will talk about GLS, right? So generalized least square. In the past, you would follow Professor Michael Binder and use the written command in Stata. Now you have to do it yourself. And maybe the GLS is a very wide area of study. We would not be able to cover everything. But from here, you will learn how to implement it, and you will develop a full understanding of the results that you have taken for granted so far. So the approach that I'm taking here in the first step is that we will rely on something that we already know, the model that we already know, and we implement the model into Python. And through that, we learn Python, right? Because otherwise, I heard from students, generations after generations, many are very active. I'm going to study Python. Yeah. What do you study with Python? They would tell me various approaches, but I think over the years, I think the easiest way to learn is to apply it to the models that we already know, right? So let's say I have no knowledge of Python until 2022, and it took several weeks for me to answer the question, how could I study Python? And if I open a book or about Python, I could not consume. So in the end, I decided to go through the book by Woolrich from the beginning to the end, doing everything in Python, just one round, and Python become pretty clear. So that is why I'm repeating that process here, because it's easier from my perspective to do it that way. Of course, it will be less structure in the way like I also take the reference from the course by professors from MIT. You know, if you type MIT 6001, you will see there are courses about Python programming. But they are taught by professors in computer science. And I feel sorry for them because I also feel sorry for us ourselves. Because when we start talking about economics, we talk as if everyone is an economist. But we don't really sense that. But now they start talking about computer science in their mind, and they, even though they were teaching to layman, they were talking in a way that everyone was already a computer scientist. That would make it very difficult to see, right? So so I am quite ambitious here. So you have to be very focused, right? Very focused. All of the name here, all of the terms here are backed by mathematical models. I have already derived them all. I don't ask you to do that. You see the formula and you just implement it, right? Because those are the things that you already know, right? So there will be no time for derivation. The results are shown. And if you have forgotten part of that, you could sit down at home and do it on your own, okay? And do it on your own. So you see that we start with a kind with the GOS and all kind of variance covariance matrix that you will see all the time in all contexts. And then we will go to the panel model. You have to derive the panel model, and then you have to do the endogenous variable. So all of them will be implemented manually to some extent. To some like the ones here, you have to derive the variance covariance matrix yourself. For the one here, we may move one step further to use some of the user written command, because in the end we cannot do everything from the scratch. But the idea is the panel models are nothing more than the extension of the GOS. So if you know the OLS, you go to the GOS, you go to the panel. It's very natural, very natural. So let's say now I just remind you of the body of the knowledge, and then it will implement it, right? Sometimes we won't use the commands that we have written. Good. So after that, we will have a section that is focused on optimization. Right. So let's say from courses in finance, you will see that all the time you may start wondering where the professor get the code from and how such a thing, how could he think of such a thing from nowhere, right? But let's say when they wrote those codes, they have the goal in mind. They already knew what they wanted to compute, because they get the knowledge and they get the goal, right? And we were students, we have to try to understand where they were guiding us. So let's say this section will focus on, Let's say when you say that the OLS model, we say that it is the ordinary least square, and the solutions to most of the results are in closed form. So what do I mean by in closed form? I mean that the statistics could be written in a complete formula, and you won't be able to compute it. When it comes to nonlinear models, most of the time, the model are not solvable. You don't have an analytical solution to all of the results that you want. And the only way to solve the problem is to use the so-called numerical optimization. Right? So we will learn a little bit about that. We will solve. Let's say you have now these are your expertise. You're expert on these things already. But let's say again, I get that what you did was to use the written command in Stata. Right now you have to write it yourself. Get it? So this is the idea. So let's say, what do you learn in Python? You learn nothing. You just ask Python like a slave to do what you want. But you have to ask in a way that Python understands you. So we often have the jargon that is very much familiar with the computer guys, but for us, it seems a lot for foreign. For example, we say we have the high-level programming languages and low-level programming languages. So when we have high and low, we prefer high. That's natural, right? But actually, high-level programming languages are those like Stata, eViews. High level, it means that they already developed into the way that is very close to the human language. So what is the advantage of that? It is easy to use, can be populated easily. But let's say it needs to be translated to the machine language. Right? So in that way, it will be less efficient, and it has already canned. It will be written. You cannot change it at will. When you have lower programming languages, they are lower means that they are closer to the computer language, to machine language. And the computer language is 0 and 1, right? So it's just 0 and 1, 0 and 1. So everything that we write, regardless of how complicated they are, can be again stored in 0 and 1, right? So the closer the program to the machine language, the more difficult it is, but the more efficient it is, right? So let's say in this case, I think Python is somewhere in the middle. It allows for flexibility, but it's also very much elegant in a sense, like many of the commands are very much close to the human language. Yep. Okay, so that's, and finally, we will have 8 90-minute sessions. That is 2 days to replicate one research paper that I have uploaded. Now, though, a word of warning here. A word of warning here. There will be a lot of work to do in that 2 days. Even though I gave you the results, I give you the data, right? But let's say when it comes to calculate the data that you need from a data set, it will take a lot of time. So the best approach to prepare for this course from now on is that you learn to understand the Vietnam's living standard measurement survey dataset. So what is that one? It is a famous, maybe the only one, comprehensive database on the socio-economic factors aspect in Vietnam. Right. So every 2 years, the General Statistics Office of Vietnam would send delegations to all over the country to make a random sample of all households in Vietnam. And from that one, they would start learning about the characteristics of the Vietnamese society. How the age structure, wages and salary, health status, asset ownership, you know, and other aspects relating to demographic and education issues. Right? So everything, almost everything about not everything, but all major aspects of the society would be recorded here. And such a data set has created thousands of research in top journals. Yeah, so it could be again for you guys to think of new research projects to develop, right? So in this case, you have to go from the beginning till the end. Then you have to replicate what I have produced there. Now, in modern research, if you publish a paper, you won't have to make your data available online. And people have to be able to replicate what you have described. So if you publish a paper, you have to sign an agreement, and they would ask you, can you share the data? Sometimes people said no, because, for example, they could do research on a specific community. But in that case, they have to sign a non-disclosure form, and they have to send the data to the editor. Okay, but they don't have to publish. For us, most of the time, you have to make available exactly what I'm giving you guys online, and people can get the data down and run the codes. If they can produce exactly the same result, you are safe. Otherwise, your publication could be recalled. And yeah, so this is a kind of, in the past, it was not the case. In the past, when I was at your age, I wrote to a famous professor asking for the data on a VAR model that he ran for European countries, but he didn't give it. He said the data are standard. You can find it anywhere. So in these days, if you publish a paper in a proper journal, they would ask you to make it available. And of course, and finally, each of you will be given one question. And I'm sorry, every two of you will be given one question. And then you will have to, I would give you some hint, but then you would have to pose a research question, formulate a solution, and try to compute data from the data set so that you can produce a research report, right? And research report. Some of the questions here we are working already. So if you do very well and you show the interest in doing research and you want to continue with your research career in the future, we would invite you to the group so that we write the paper together and you would be the co-author. That's what my goal is. Right? So that is the introduction to the course. So I have to say that it will be very. So let's say for the first day, let's see how I'm not 100% sure how fluent you guys are and how heterogeneous the class is. So we just start a first day with some trial and error and see how far we can go, right? How far we can go. After that, let's say with all of these contents in 2 weeks, it will be very much demanding, very much demanding. So I beg for your support. If you are not good, the program is not. And I know that so Links is working on a project to explore what the other research program, other master programs are doing. We know that they are not doing this one, but we are doing research-oriented tasks. If we do it better than the other Vietnamese competitors, but we are not do as well as the international competitors, we are nothing, because we do not compete at home, and we compete internationally. So for that reason, the course will not be easy, right? Will not be easy. So I beg for your 100% support from you. We could go as fast as we can with the support of ChatGPT, with the support of Google Gemini. It's fine. I have no problem with that. But the thing is, after the course, you feel familiar, right, with Python. And if you want to do something, you can formulate a question, and with the support from the ChatGPT or from one of the AI assistants, you would be safely proceed with the and produce meaningful research, right? Okay. So with that, I want to close the introduction today, right? You will have no examination. The admin side just send out the email, standard email. You will have to write the research project. So I will not be able to. I will not be able to prevent you from using AI. So I will control the quality of your research. Several things that I will look at. The first one is I will run the code, right? So you have to write it, the research report in the form of a research paper. Of course, it doesn't have to be very long, but it must have the research question. It must have the research methodology. It must have the results, and you have to present it in a way that is look like a publishable paper. Right? What do I mean by publishable paper? It's like the paper I have provided to you. So don't copy the interface of the software and give me this is my table. That's not the way it works, right? So you have to create publishable papers and the most important thing is that I would go from line by line of your code, right? And if it is simply written by ChatGPT without breaking down the meaningful calculations, I would ask you to my office to explain. And the final grading would be a combination of the quality of the code, the quality of the reports, and also the quality of your performance during the class, right? So with that, I hope we will have a productive 2 weeks together. It's no longer 2 weeks, right? In the end, in the beginning, I gave you 2 days, and I thought it would be fine because you just finished the course by Michael Binder. I think you need some sleep. But but in the evening of Tuesday, on late Tuesday, I got a message that I need to attend the whole day meeting on Wednesday for implementing the ideas from the house from the seminar. And yesterday I got the message that I would need to attend the meeting this morning. So it keeps going in that way. So now it's no longer 2 weeks. It will be unfair to push you to go through the research question and presentations with it by the end of the next Friday. So let's see how far we can go. Maybe the presentation will be done after Mehdi's course. I will give you some more time to prepare. Now, so Mr. Minh, you have a question? Separate. Individual, right? So I would compare the effort. That's how. Then, I mean, like, are we allowed to? I think it is individual work, right? It's not teamwork. I don't allow teamwork here. So let's say I know that you can cooperate, right? But experience has it that if you do, you are given the same research question, right? You will never come up with the same result. And if you imitate each other, it's very likely it will show up. Yeah. So last year, for example, I didn't see that people cooperate that much. I did see that they try to help each other with the code, right? The code. For example, they ask each other when they get stuck in getting some. For example, this is the idea. You have a family with a lot of members, right? And then now you want to compute, but in that family, it give only one information, that is, for example, you want to compute the average wages and salary of the children, right? So how can you extract the data, because it has only one identifying number, that is household and members, but it would be very difficult. There must be some computation to extract the data. So I did see that people ask each other on class and the like, but in the end, I think they compete. They competed quite strongly with each other. So the part they try to make it distinctive were there, and that's the message to you guys. You try to make your research very much distinctive. Let's say that is a kind of scientific exploration that you have come up with. And believe me, no one would ever, if you give one data set to two person and you ask them to run to the same research question, they would never come up with the same answer unless they cooperate. Yeah. So let's say I have ways to identify. Last year I only released uh 2 days. Let's say 2 days before your presentation, because there won't be a section on presentation. Two components, right? You have to present your. Let's say you were given the question and you have 2 days to dig into the data and present a solution. How I am going to answer that, right? Answer that. So let's say if time doesn't allow and we have to slow down, the course will surely prepare you enough for the financial econometrics by maybe. Then after maybe course, we will have the 2 days presentation. I can give the answer, the question right after quite early on if you want. But let's say if I give it early on, I will give it to everyone, right? So let's say that will make sure that everyone gets the same starting point, right? Good. So let's say let's have a vote. Let's have a vote. If you want to have the question now, I will send it in the evening today, right? And I will assign immediately. I will not allow the kind of self-selection, right? I will assign the questions randomly. I know I'm doing that in that way. I would not know who will get what. Who will get what, right? Good. So in that way, you would need the question this evening, or you would just want it 2 days before your presentation. So if it's 2 days before your presentation, it will be very much pressing, and everyone have to start working. That is a way that I did last year. So it would be quite demanding. And if it is given early on, then I would expect more complete answer, right? I will send you a rubric of the evaluation points I want to look at, right? So let's say which one would you want to have? Let's say this evening or 2 days before the course. Okay, so the majority is saying, what is you wanted to close to the course? You have no idea. I don't know. Okay. Good. So let's say I'll send it out in the evening. Okay. Now, ladies and gentlemen, these are the course that you may need, right? So let's say the theory, most of the theory comes from here, and I hope this is now one and for all. You would master the basic, the foundational knowledge of econometry when you graduate from the program. So this is once more to reiterate what we have taught you so far, right? And then that's where when it comes to applications, most of the time it is this one, right? Or using Python for introductory econometrics. Let's say so those are the books that you need to pay attention on. I think this one may be very much interesting for someone who wants to dig deeper into the kind of general computational thinking from the computer science perspective. So this is by a famous professor in from MIT. And the third one here is a book simply for focusing on using pandas. here and there I would take the explanation from the book. I need to explain to you why certain commands is written in certain way, right? That's it. And so thank you for this part. I think we have only 30 minutes left, so that there won't be no break. Okay, no break. And we won't come. We won't start again at 1:30. 1:30. So you have 1 hour lunch break. Okay. So Khiết Anh, are you with us? Yes. Okay. Thank you. Can you hear me well so far?
Yes, I can hear you very well.
Okay. Good. Thank you. Yeah. Okay. So this is the data, right? So you see that when the people provide the data, it is at the commune level and it is at the household level. You see that they are provided to you based on the so-called section mục, right? And the data would depend on when it comes to that, you go to the document here, right? And then you would see that you go to the questionnaire, you open it. So mục O1, 1B, that this is to say when you click on this one, you would see that the questions are, for example, you would open the data set and you would see MOU1 C1, that is mục O1 question 1. It would record the information here. Okay, so each column of the data will give you one information, and the let's say the data provided in the data files are corresponding to the questionnaires that is provided here, right? So let's say you imagine all of these information here, right? So you will see that each column will be one variable. Right? Each equation. Sometimes one column could be two variables, and the variables are recorded in the data format. Nowadays, it is mostly provided in the data format. So, for example, if you go to MOC1A, right, MUC1, right, here, you will see that it is the data for, of course, let's say before going to Python, of course, we can have a look at something that we are very much familiarized with. That is Stata, right? So it is in Stata format, and you see that, of course, you would start seeing immediately that the data are the label of the variables are not properly displayed in the data windows, because the software is not yet fully compatible with the Vietnamese language yet. But I think from you look at the name of the variable, you won't be able to check what the meaning is. And the only way to write a research report is to fully understand your data, where it comes from, where it comes from. So, and then at some point in time, you may have a lot of research papers or not because if you are properly trained, I mean, not because you have idea or not, but it's just simply you have time or not, and you have the perseverance to pursue the question until the end, right? So, so hopefully, and then also to some of you who truly want to go to the USA or somewhere top universities in the UK for PhD, a research publication in 6 months could be something very much rewarding. Yeah, very rewarding. So if you feel now, if you find the motivation, the interest to dig deeper into certain research area, given the kind of quantitative methods that you have been equipped with, you can develop a research career in any direction. the direction that you choose depends on the knowledge that you have. So let's say the link in the program, you will see that the quantitative methods are the tools, and specific subjects like economics, microeconomics, macroeconomics, asset pricing, corporate finance are like the torch, like the guiding light. So it gives you the knowledge about the theory of different aspects of the society. And if you want to research more about that, you use the econometric tools. That's the idea, right? Okay, so that's why we need both the theoretical models and the quantitative methods. Okay, good. So let me come back to the slides, right? So you may see that I have used very simple econometric knowledge. Let's say we are not learning econometric here. Okay, and of course, you have the right to ask me immediately when you want, right? So let's say, so I have changed the name of the file into part one because in the morning I put it day one, and I know that we will not be able to cover everything in one day, right? But basically, this is the idea that what we are going to do. So I start with some simple math, and I would ask you to say, now you know how to do it. Principally, do it in Python, right? So that's it. That's a very simple thing. For example, for the computer guys, I would say you know how to inverse the matrix using the Gaussian methods. You program it. You have to play fair with me. You have to play fair with me. If you copy it, you put into Python, you would put into ChatGPT, you would get the answer. You would get the answer one way or the other. Sometimes it gives very the answer that is very foreign, but it still produces results. Now, I think if you just do that, you would learn nothing. So you will try with the step by step, and when we get stuck, you can try with the help from ChatGPT. But let's say basically, I would guide you through different steps, and you have hopefully you will have a framework to judge when you need certain techniques, right? So let's say in order to you will see that I start with the math, right? All kind of math that you need to the basics you need to know. For today, I would very much let's say, for example, here this is the idea of you have different ways of computing the inverse, right? You can have the determinants approach. You could have the Gauss-Jordan approach. You can have the LU approach. But let's say this is the Gauss-Jordan approach. So basically, you would put an identity next to it. You would try to manipulate until when you get an identity on the left, then you get the inverse on the right. Do that with Python. Right? Do that with Python. You have to do it manually in Python. Right? So if you can do that, it's very simple. If we keep going, gradually we get used to data, to Python. That's how we learn Python. Right? So do you know what you want to compute? Yes. Right? And just simply go step by step to get it done. So you have in a slide like this one, you have a clear instruction on what you want and what is the goal, right? And you can check if the results are correct, right? So going through, I would stop and we would start doing it on the on Python, implemented on Python. Now you have the calculus here. The calculus here, I will skip. I will keep it for the continuity of the discussion because you need that in our later results. But we will come back when we talk about optimization, because when we talk about calculus, nothing more than optimization. So the second part of the course, we'll come back with the discussion here, right? We come back with the discussion here. So you will see the definiteness and those ideas. You may recall that I talked about matrix calculus. So those are just included here for continuity, but they are theoretical results. But I just want to remind you so that when I present the results, you will understand it. For example, I would talk about the eigenvalue, eigenvector here. You know about it. It will be very brief, right? But let's say basically then we would use some of the we will use a simple written command in Python to get it. So let's say many of the results here are presented for the sake of completeness. So that's say if I jump from one result to the next, I may run the risk that the students just don't know, just have forgotten how could I do that, right? So let's say this is a reminder, and if I need to stop somewhere in the middle, I will. But otherwise, I would keep talking very quickly, and I would come to this one. Of course, this is the OLS, simple one. You have to program it manually on your Python, how to get the results, right? So go on with the regression table. You won't be asked to produce all of the results, and let's say you will be asked to implement the Fitzgerald-Lowell theorem in Python. So those are the results that you need. So the results are here. The theoretical results indicate the meaning and the applications of the model, and the Python is a practical one, teaching you if you know how to implement something that you are familiar with in Python, then that is the easiest way to learn Python. So let's say you see that we go through it, right? We go through it. We talk about the R square. You will compute the R square in multiple ways using Python. So that's the thing. I mean, going forward, when you have to do a lot of things in Python, you get used. Okay. Good. And then we go through with common distributions. Here you will have to simulate. This is the realm of probability. Of course, you have to simulate in Python to get the graph that indicates the properties of the distribution. For example, here, this is done in Wikipedia. You have to do it with Python, right? So how can we do that? That is something we reproduce exactly the same thing. So we will in these activities we will go to the realm of the empirical distribution. When you want to examine if a variable is normally distributed, how can you examine that, right? So you will be able to do those. We often back then Professor Alexei often made the joke to us. That is the so-called eyeballing methodology. So you would grab a variable and you look at it. You grab several variables, you look at their relationship, and you try to discern certain patterns. Yeah, so descriptive analysis, simple as they are vital in identifying certain interesting research ideas. Most of the time, when you start with certain research idea, you come up with a very different one, and that different one would give you a publication or would make your boss happy. Okay, so that's what we can say, right? So let's say I would present the results, and you have to produce the graph. Of course, we can compare with the code that I have written, but there are multiple ways of doing it. For example, this is a chi-square with different numbers of degrees of freedom. So if you were able to do all of these by the end of the program, you will feel very comfortable with Python, right? And this is simply the chi-square. It has a lot to do with this, the so-called central law of large number and the central limit theorem. Basically, you see that the chi-square is skewed to the right when the number of degrees of freedom is small, but it tends to a normal distribution when the number of degrees of freedom becomes large. So you will see that. And interestingly, now you have the time to simulate and absorb the idea, the knowledge yourself, right? And then we would talk about the t-distribution. Normally, you would hear a professor in a class saying the t-distribution is only meant for the small sample properties. When the sample gets large, the t approaches the normal distribution, the standard normal. Now you have to show it and then truly understand why that is the case. Here and there, the professor have already mentioned, but now is the time to review, right? So the strategy again is to review something that we already know. It sounds familiar. Now we get theoretically clear why it is the case, and then we will demonstrate that using Python, right? For example, you may get someone stated clearly somewhere in their lecture that the F distribution is the chi-square distribution that is rescaled, right? So if you take an F distribution times the number of distribution of number of degrees of freedom, you would get it something that is similar to the chi-square. Can you show that? This is what we have, right? So let's say just implement it. Right? Just say implemented. So these are the necessary skills that you would need if you want to do empirical research. Because by graphing the data, the true data, you will be able to detect the distribution and the tendency of the data. And you can detect the interesting relationship that you may want to explore. Good. Okay, and then we will talk, of course, this is the part of the regression table. All of these numbers must be computed manually, and it will count. It will, in the end, it will. We will end up having producing the same the regression table that looks like or looks more beautiful than the one usually produces by Python, right? So this is and then the results like this one are simply for the sake of completeness, right? But then we will come to the so-called the issue of law of large number and central limit theorem, and you will learn more about truly when you do the courses. Maybe sometimes Professor Binder may say the results are generally holds when the sample is large. So what do we mean by the sample when the sample is large? What is the law of large number? What is the advantage when you have a lot of data accumulated in one data set? What is the meaning of that, right? So let's say graphically, you will see that basically the statement is, you may see here from the professors, a statement something like, the more data that you have, the more precise your estimates are. What do we mean by more precise? You will use Python to simulate and see that if the sample gets large, the variance gets smaller. And if the sample is very large, you see that the estimate is here and the variance is very small. It is 2.9999 and 3.0157 or something. So let's say if the number is 3, if you get up to 100,000 observation, the confidence interval, the 90%, 99, 95% confidence interval is 2.983 something and 3.0157. So 2.9 to 3.1, 3.01, right? They are very close, meaning that if the data, the sample is large, your estimate is very precise. And now you can demonstrate that empirically, and you feel boosted in terms of confidence of the statement that we used to make, right? So all of this requires very little knowledge of what we have done, because I would present to you the theoretical results before we apply, right? So this is the first section. Of course, here I will manually prove the central limit theorem and the central and the law of large number idea, or at least explain it before we implement these simulations, right? But basically, along the way, we get used to Python, right? Good. That's the first thing. So we are done with the content of the first section that we expect what we are going to do. So let's say even if before we go to the class, you see that if let's say let's spend the next more than 1 week, right? When May comes, you must focus on finance, but with a boosted energy because you know Python already and fresh, so that when he wants you to do some kind of optimization, you would know, right? You would know how to start, or at least the kind of optimization function that he writes down may be different from what we are doing here, but you know the idea behind, right? Then with the next session, we will learn on how to do it, apply it to the research in a cross-sectional setting, because maybe we'll focus on time series and I don't want any overlapping, right? Good. With that, I make sure I'm quite sure that all of us have Python installed, right? Very much. So you did it in Fabian's course, and which any other course? Fabian, right? In Fabian, you use that Woboking, right? Omer, right? Fabian and Omer, right? Okay, good. So let's say I hope that Python is now ready, and we will start. Let's say we will start in 1.5 hours, and when we start, we will go directly to Python. And I would encourage you to say, I will go from here to here, the whole set of more than 100 slides. How can I do that on Python, right? I don't need Dr. Ha to be by my side all the time, but I will be able to reproduce all of these results. And I appreciate the theoretical results that I have done so far, right? Okay. So with that, say 6 minutes left. 6 times 8, 9 is 54. So I cannot waste, right? But what I can ask you to do is making sure that you have all installed Spider. Can you open Spider? Because in Fabian's presentation, I guess he used Google Colab. Okay. Or someone would use Jupyter Notebook. Jupyter Notebook is quite handy in terms of co-authoring, sharing the codes and cooperating. But let's say for pedagogical purposes, Spider is better, because Spider is more closer to a language like it is just an interface, right? But the interface is more or less like Stata or eView, when you can open the data and do the eyeballing methodology again. Of course. So each has some advantages. I know that Jupyter Notebook is quite popular. But let's say if the code works on both IDE, right? So if you want to use Jupyter Notebook, fine. Last year, Sun Mai kept using Jupyter Notebook while I was lecturing in Spider. It's okay. But let's say sometimes there could be a little difference, right? Yes. Okay. So let's say, can you please open the let's say I would explain later, but let's say if you can open the if you can open Spider in your computer and make sure that everything is ready, so that we will be able to start the coding right in the afternoon. So let's say the message I would have for you is we will cooperate together in the next 1.5 weeks. together, if we can do certain calculations, if we get used to, we can reproduce all of the results in the slide, right? The, the idea is that we reproduce something that we know, and we keep doing it continuously for almost 2 weeks. Then we get used to the language, right? Nothing more. But so this is something that I need you to be able to open, right? So everything is there. So I have prepare a little bit of code here. Sometimes I would put the note on that for the first few days, because it could be superfluous or redundant for someone, but it could also be meaningful for the others. Good. So let's say if you are sure that your software can run, then you can run for lunch. Right? Yes. So everything is fine. Everything is ready, right? Okay, good. 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 Link, I trust that everything is very good. Okay. Mm-hmm. Yeah. Chí Trung, fine. Okay. Good. Okay. So it's 28. Any question? Yeah. Last year I gave a different data set for someone. But let's say if I give a different data set, I give the very clear explanation. Most of the time it will revolve, it will rely on the same data set, the database, right? But the focusing on different things. Last year I gave a different one, and this year I'm intending to give a very different one to Minh Quân, and because last year Minh Quân used the US data, right? The US stock market data. Well, let's say last year, because of the an urgent research question, I gave a very different data set to 2 students. Right? But let's say if I give a different data set, I have that data set in mind. It will not require a lot of preparation, but it will require a lot of other aspect of data management, because it is a worldwide data set. So let's say they will not be too different. Yeah. Okay. Good. Yeah. So let's say for the problem, for the research question, one is that I am going to send out the research question and the assignment today, right? I will send out the rubric of assessment also today, so you know what I expect. Then we would keep going, and it depends on very much on how fast we can go. But my plan, I mean, after all of the households from the start, when I have to attend the school business, my take is that we would go to this session by the next Friday, right? By here, right? By the next Friday, I would give you one day off. That is Wednesday, right? Then by the next Friday, we will finish until here. So let's say we will. So the more we can do here, the more fluent you are, the better. For the happier I am. Let's say we will finish until here. Okay, until here, and the 6 sessions would be arranged after Mehdi has left, and maybe after your examination with Mehdi, 2 days after your maybe a week or so. Let's say you will face other examinations, right? You will face other examinations. So when is the next examination? 13th of August, maybe, right? And then when is the next one, the following one? 25th, right? Oh, so then let's say we could meet on. I would expect you need 2 days to formulate your presentation. So if it's the 13th, then we would likely to meet on the 15th or 16th. It depends a little on. I won't finalize the date because my schedule is not clear by that end yet. But let's say it will be a few days after your examination with Mehdi, right? So the course here it is not to, let's say, basically not to earn the grades, but let's say to develop the skills that you truly need. PowerPoint and code. Right? I would stop the student in the middle asking for the code in no time. Right? Yeah, for instance, not the result yet, not the result yet, because you explore the data to talk about the challenges that you face in the data, the approach for computation, the way that you have prepared the data, but not yet the result. The result will be for the of course, if you have the results, you can talk about that. But let's say the final results are not expected. It will be due in let's say in 10 days or a week or something. You can write the report, right? Yeah. So let's say the rule is if you use ChatGPT, if you use Google Gemini, why not use it? Because that's part of our life now. Use it to do beautiful computations that would show some keen observation on the data. But let's say you have to tailor-made it into your own code, right? Just don't simply copy it and paste it, because when I click on it to run, if it doesn't run, I would not want to punish anyone. But that would be an indication that I would not trust the code, right? So let's say like I am submitting to a journal, I have to create all the files in a proper way, and then I would write a small piece of code that if the person click on it, it will run from the beginning to the end without any complaint. Right? So I would expect the same from you. For example, now if it is abstract from your side, this is what I did, right? So say when we submitted the paper to a journal, right? When we submit a paper to a journal, there must be let's say this is what I have, right? So let's say you have to make sure that when people run the code, there will be no complaint. Right? There will be no complaint. For example, here, if I open, so you see that yeah, so this is all the data that I have to submit. Right? So you have the original data. So you have to copy the data that you buy from the data producer. You put it there. And you write the code to go to that folder to get the data and extract the information. So people, if they don't have your own original data, but they copy the original data from somewhere else, they put it there, it must work the same way. Right? So this is an ethical issue to prevent people from modifying their data when to serve the certain research direction. So let's say there will be a README file, right? The README file here will explain what the meaning of the files are. And then if you, for example, here in the README file, I would explain, right? So for example, here I would explain that this document contain the data in certain way. So let's say one is Interested readers should start by running the following script to clean the data and construct the relevant variables, right? So let's say you have to click on this one. So with 1.1, if they open 1.1 here and they click on run, right? So let's say they would expect the, of course, we because when I wrote this one, it was in Stata, but basically I would expect the same thing in Python. The idea is that when people start running, it should produce the same results without any complaint, right? So let's say this is what I have here, right? So let's say if I click on run, this is, wait. Now I don't think that I made a mistake. Control H D, this one, because I changed, I reinstalled my computer some time ago. Happen. Replace all, right? Good. So let if say because of the directory, but if I click on run, original that's not found. Why? Hmm. I think this is simply because the software doesn't have the copyright. The let's say, let me open it with administrator, right? Yeah. Okay, let me check it again with the recent file. Now let me open it. Mhm. Okay, so this is what I would expect. So you would have for me a an explanation file, what you have done and how I should run the data, right? So let's say if I click on this one and if I click on running, I would expect to see that the software would start running. Ah, let's see what is the problem here. One of the problem could be that, let me open it. Okay. Okay, so let's say this is sorry for the for submission. Ah, I see. So because just some of the code that I have written, right? So let's say global CD runs. Okay, use. What happened? Not found. Okay, so I manage it. Then we'll start running from beginning to the end because of the a little bit of the data directory. But let's say we will come back at 1:30, right? 30, and then we can go on. Good. Hello, Kiệt Anh. So we take a lunch break now, and we will come back at 1:30. Right?